How's it going, guys? So today we're going to be looking at question 22 for histograms. Okay, so let's read the question here. The histogram shows information about the weights in kilograms of some newborn babies. So it is. Some parents have a bit of fun anyway. There are 35 newborn babies with weight less than 2 kilograms. Okay, so um, very light babies. So they are. Okay, so that would mean, so if we've got 35 newborn babies that weigh less than 2 kilograms, it kind of means that this region here represents 35. Okay, so um, the first step we might take is to find out this frequency density. Okay, so we know that the frequency of this area and this area add together are 35. Okay, so what we can do is we can split it into the bigger blocks. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 blocks. Okay, and 14 blocks represents 35 people. Okay, I'm working on ratios, that's a wee bit easier for me. Okay, I want to find out what one block represents, so I'm going to divide both sides by 14. Okay, so that'll be 35 divided by 14. Okay, and then I have 1, 2, 3, 4, 5, 6 blocks here. Okay, so it'll be 6 multiplied by 35 over 14, and that would give us the frequency, or how many babies were born in this first block. Okay, so what I'm just going to do here is I'm going to rub out my dots because I don't really need them anymore. I'm going to work that out in the calculator. Okay, what I'm thinking is 15, maybe 6 times. Yeah, it could be 7 over 33 times. Yeah, because 35 over 14, you can divide top and bottom by 7. So you can, then the 2 crosses with a 6. I'm just doing the mental maths in my head here. So 14, yeah, 15. Okay, excellent. So this block here represents 15, and if you didn't know, frequency density is actually equal to, well, should I say frequency? I'll work with frequency first. Frequency is equal to frequency density multiplied by the class width, not E width, class width. Okay, so the class width here is actually just 1.5. Okay, I'm actually going to rub out this 35 here. Okay, so it's 1.5. So if we rearrange this equation, it would be frequency divided by class width is equal to frequency density. Okay, and our frequency is 15. The area of each of these shapes is the frequency always. Okay. So 15 divided by 1.5, that would give us a frequency density that's equal to 10. Okay, so this is 10, this will be 20, 30, 40, 50, okay, and so on. Alright, so now that I've got all that working out done, I'm going to rub it out, okay, because I want this additional space for myself. Okay, so if you need it, copy it down. If you have any questions, just write in the comments below, and I will do my best to answer them. So I will. Okay. So, what we'll do now is I'll just work out the frequency of all these, all the classes. Okay. So the next class is we've got a width of 0.5. So 0.5 times by 40, which would give us 20. So the area of that object's 20. Okay, this bad boy here, we've got a width of 1, height of 50, so all of it represents 50. This is 0.5 and 22, so that would be 11. This is 0.5 again, and it looks like 14, so 7. Yeah, 1, 2, 3, 4. Yeah, 4 above. And this is for the this is width of 1 and height of about 6. Yeah. So in total that represents 6. Okay. So let's take a read at our questions. All right. So calculate an estimate for the number of newborn babies which weigh between 2.5, so here, and 4.5, so here. Okay. So what I'm just going to do is I'm just going to shade this in with a different color, just so I kind of know what I'm looking for. Now, where is my pen? Where's my pen gone? Okay, there it is. It's kind of hard to see, isn't it? Give me a sec. I'm just going to go, can I go black? Yeah, that'd be a wee bit easier. With the yellow, Jesus, I feel like I'm colorblind. So what I'll do here is I will color in this area. Okay, so we're looking for this whole shape here, this whole shape here, this shape here, and this shape here. Okay, that's how many babies were born between 2.5, which is here, to 4.5, which is here. Okay, so I'm gonna rub that out, rub this out, get my pen, 2.5 here, and 4.5 here. Okay, so I know this full shape is 50, so half the shape would be 25. I know this shape's 11. Okay, 7. This full shape's 6, so half this shape would be 3, so it would be 25 plus 11 plus 7 plus 3. Okay, and that would give us 25 plus 11 plus 7 plus 3. That would give us 46. Okay, 46 babies. Now let me just make sure. 25 plus 11. Yep. Okay, excellent. Okay, so 46. Tactical. Alright. So what we can also do here, because I imagine it's histogram question, we'll probably have to work out the median. Okay, so what I'm going to do now is add all our frequencies together. Okay, and I'm going to rub out anything that is inessential. Okay, so I'm going to be rubbing out some of my values as well. So that was 6 and 7. Okay, 6 in here, 7 in here. Okay, we don't need that 25 up there. That just represents what half the value of the bar is, yeah? So, let's add these all up together. 15, so, total babies, alright, so total number of babies that were being born. Okay, so 15, plus 20, plus 50, plus 11, plus 7, plus 6, 109. Okay, so 109. That's the total number of babies. Damn, that's a lot of babies. So as I suspected, median weight of a newborn baby. Okay, so when we're finding the median, the equation is not n is equal to, but n plus 1 divided by 2. So n plus 1 divided by 2, where n is the total frequency, or total amount of something, yeah? So in our case, that is 109 plus 1 all divided by 2, which is 55. Okay, so we're going to have to look at our bar chart here, our histogram, should I say, and try to find the 55th value, okay, which isn't too bad, alright? Now, I know this represents the first 15 values from here to here, so this represents the first 15 values, yeah? This area here. This represents the next 20 values, so would be at 35 when we come to our line here, okay? And we know that this represents 50, yeah? Half it represents 25, okay, in terms of frequency. We're looking for, so I know from here to here is 0.5, and I'm just going to kind of dot it up here. Okay, I'm not very good at freehanding, but this area here is 25, yeah? So I'm looking not for this 25th or middle value, but what I'm actually looking for is to get my 55th value. I would just add 20 on to my 30th, okay? So I know my width is 0.5, so I want to find out what each individual block represents, okay? So that would be 25 or 0.5 divided by 25, and that would give us 0.02, and we want to get the 20th value in here, so it'll be 0.02 multiplied by 20, that just gives us 0.4. So we're actually just going to go for the fourth block in. That's the third block, fourth block in. So that'd be 2.4. Yeah? So it is, because we're just going in across here, and that would be our 55th value. Okay, I hope that makes sense. So it is essentially what I'm doing is finding out how much each little block represents, and then trying to find the 20th value in this block of 25. Okay, because we already know we've got 15 here, 20. So when we already are on this line along here, run the 35th value. Yeah, so we know the middle value here would be 35 plus 25, which would be 60. So we know we're somewhere in between here and here. Okay, I hope that kind of makes a wee bit of sense. If you have any questions, again, just write in the chat. So I know my value is going to be 2.4. Okay. Okay, so next, calculate an estimate for the interquartile range. Okay, so our median is actually the middle value. Yeah, so what we can do is we know our median is the 55th value. We can divide it by 2, and that will give us our Q1. Okay, because our IQR is equal to Q3 minus Q1. Okay, so our Q1 is 22.5, and we can just add this on to our Q2. Our Q2 is just the median. Yeah, so we can add that on to our median to give us the Q3 value. Yeah, so that would be 77.5. Okay, and now we're going to have to go back to our histogram and find the 22.5th value and the 77th 0.5th value, and the actual value in kilograms. So if you're going to cooperate with me here, thank you very much. And I'm just going to rub out all of my working out here, because I'm going to go back to the drawing board. Okay, so I know that represents 50. I can just write that in again. Represents 20. So 20 and 50. So we're looking for the 22nd.5. So Q1 22nd.5 value, and Q3 is the 77.5 value. So we know what this value here represents 15. Okay, so I know the 22nd.5 value is going to be somewhere in this long column here. Yeah. So what we can do is, we know that the width of this is 0.5. We know we have 20 values in it. So again, what I would do is 0.5 divided by 20, and that kind of gives us the value of each block. So 0.5 divided by 20 is 0.025. Now, what I'm going to do here is I'm going to actually work out the difference. Since we're 15 up, all we're looking for is 22.5 minus 15, and that's how many blocks we're looking up. Okay, in terms of here. So it'll be 22.5 minus 15, which is 7.5. Okay, so I want in terms of this 20, I'm going to look at the first 7.5, or I'm going to go up the 7.5th frequency value. Okay, so what I'll do is 0.025 multiplied by 7.5, 0.25 multiplied by 7.5 gives me 0.1875 kg. Okay, so I know when I'm here, I'm at 1.5, so it'll be 1.5 plus 0.1875. Okay, what we can actually do is we can just work out the kilogram in weight, so we can along here, because essentially the width of it is 0.5 kilograms, so we're finding what each block represents in terms of kilograms. Okay, width wise. So that means that our Q1 value would be 1.6875. Okay, and now we're going to look for our Q3 value. Okay, so we're going up. This is 15, add 20, so that's 35. 35 add 50 is 85. Okay, so we're somewhere in this bad boy here. If I split it in two, okay, again, I'm not very good at freehand. The first half represents 25, so 35 plus 25, that would be 60. So we're going to be somewhere in here, okay? And I know this is 2.5, and our width here is 0.5, okay? And I'm going to write that 50, okay? Because this half represents 25, just like that half represents 25. Okay, so it's going to be, again, 0.5 divided by 25 to find out the weight of each block. Okay, so 0.5 divided by 25 gives us 0.02. Okay, and at this point in time, when we're in the middle here, okay, we're at 60 for ourselves. Now we're looking for 77.5. So what I would do is 77.5 minus 60 gives us 17.5, okay? And that's how many blocks in we're looking to go here. So we are okay. So what I'll do is, as I'd done before, multiply the value of our block by how many blocks we have, okay? So that'll be 0.02 multiplied by 17.5, which gives me 0.35, okay? So that means in here kind of represents 0.35. We're already at 2.5, so it'll be 2.5 plus 0.35, and that would give us 0.85, or no, not 0.85, 2.85. Okay, so we have our Q1 and we have our Q3. Yeah, so that was the Q3 in terms of its frequency value, but now we have it in terms of its kilograms, yeah? So it is, I hope that kind of makes sense. So again, we're at the 60th value along this middle part, and we know that the 77.5th value is in here somewhere. It's in between the 60 and the 85, yeah? Because this end block here would represent 85 when we add all the 15, the 20, and this whole block is 50. Okay, so what we can do is, again, it's going to be Q3 minus that's me. IQR is Q3, which was 22.85, yeah, minus 1.685, I think. I'm just going to check again. 875. Okay, 875. So our IQR is equal to 2.85. Take away 1.6875 is 1.1625. Okay. Now, as you can tell, right, if you've come to this point, these questions are quite long, and for the marks, they're not really worth it. So what I'd recommend doing is tackling other questions first. So it is, histograms generally are complicated and depend on how they word it and what information they give you. They can be a pain in your arse. Okay, so I recommend skipping it and leaving it to the end. All right, if you have any more questions, just ask in the comment section. All right, see you in the next one.